Welcome to this video. I am Physics and today we are going to be going over moments. First of all, what is a moment? A moment is the turning effect of a force acting on a point called the pivot. Moment of force equals Fx, where F equals force measured in newtons and x equals distance from pivot measured in meters. So now we are going to be going over a GCSE physics exam style question where it states that the seat of a swing AB is 0.8 meters long. A person of weight 450 newtons sits on the seat. The person's weight acts at a distance of 0.5 meters from A, as shown in figure 3. The upward forces exerted by the rope on the seat are F1 and F2. Calculate the force 2 by taking moments around A. So over here we can see that we have A and we need to find moments around it. So to find a moment, we need to do F multiplied by X. And as it is in line, so it's just horizontal, we can say that the moment due to F2 will be the same as the moment due to the weight of the person, and they're going to equal each other. So if we find the moments using Fx, so we do 450 multiplied by the distance, which is 0.5 from A, which is over here, so multiplied by 0.5, and that will equal to F2, which we don't know, multiplied by 0.8. And so if we divide 0.8 on both sides to get F2 by itself, you can see that F2 will equal to, so times 0.5, then divide that by 0.8. So we'll get 281.25 newtons. And that's the answer. We are going to be going on to an A-level physics and maths exam style question, where it states, calculate the minimum force of the wind Fw that will cause the basketball set to be blown over when is an angle shown. Ignore the effect of the wind on the base. Weight of the post arrangement equals 27 newtons and the weight of the base equals 868 newtons. So you can label this side as section 1 and we can label this side as section 2. And as we want the minimum force, we can say that section 1 and section 2 will be equal. So we're going to be first working on section 1. So we want to find the moments due to the weight of the base. So, and we want to find the moment from this point over here. So as we can see, it's at an angle. We need to add that into our calculation, as we want to find out the perpendicular force due to the weight of the base acting on the base. So it will be perpendicular to the base. So we need to use the formula moment equals Fx. So 868, which is the weight of the base, multiplied by 0.45, which is the distance to the point circle in red, 0.45 multiplied by cos 15. Due to angle rules and trigonometry, we found 15, and we know it's cos. So when we do that, we'll get 377.29 Newton meters. So now we need to find the moments in section 2. So we have the weight of the post arrangement and the weight of the wind. The force of the wind. So first we're going to be working with the weight of the post arrangement. So we need to find the perpendicular force acting on the post arrangement due to the weight of the post arrangement. This angle here is 15 degrees due to angle rules, and as it is perpendicular and the angles add up to 90 degrees, so therefore this angle will be 75 degrees. So we can do the weight of the post arrangement, which is 27, multiplied by the distance, which is 2 meters to the point in red, and you do that times cos 75 due to trigonometry. So 27 times 2 times cos 75. 13.98 Newton meters. And now for the force of the wind, we want to find the perpendicular force on the post arrangement due to the force of the wind. And we can see that this angle will be 15 as well, as that's due to angle rules. And so we can label it. So as we don't know the force of the wind, we can just write Fw multiplied by the distance, which is 2, plus 0.4, which is 2.4. And we can do that times cos 15 due to trigonometry. And we can just label it as x. But as we said, section 1 will equal to section 2. We can write 377.29 will equal to 13.98 plus x. And to find x, we can just take away 13.98 from both sides, and that will give us and that will give us 363.3 Newton meters. And so as we found x, we can just divide both sides by 2.4 cos 15 to get Fw. So when we do that, we will get Fw equals to 157 newtons. And that is the answer. Don't forget the newtons. And don't get confused with Newton meters, because it's asking for the force. So thank you for watching this video. I hope you have learned something from this video, and it would be really appreciated if you could share this video and subscribe. Have a fantastic day.